this is Sriram. Welcome to Sriram Creations, and I'm presenting you a brand new video, totally depending upon chemistry. The topic is chemical bonding. Hold on, let me grab the marker, and here we go. So here we have the chemical bonding, which is a branch of chemistry, and we are going to deal today bond length, bond angle, Lewis dot theory, and the types of chemical bonds. Ionic bond, covalent bond, and polar covalent bond. So first of all, what is a chemical bond? Okay, to understand that, I'll just give you an example. Imagine that there is one atom over here, another atom over here, and they both need to get stable configuration. That is any one of the helium, neon, argon, krypton, xenon, radon. Okay, any of them, any of their configuration. Now, these are two random electrons or atoms. They have to combine. Now they have to combine, right? So the bond which will make these both to combine is known as chemical bonding. So let's get to the definition. The attractive forces between two atoms or ions to form a molecule or in a molecule is known as the chemical bonds or chemical bonding. Okay, so there are three types of chemical bonds. I think everything is clear. If not, rewind the video so that you can understand it better. Okay, so there are three types of chemical bonds. One is ionic, covalent, and polar covalent. I'll give you random examples, so then I'll come to each definition so that you can get a perfect idea about these three types. Now, first of all, I'll come to the ionic bond example. Take NaCl. You know this molecule? That's sodium chloride. Now, sodium has its atomic number is 11. Now, 11 atomic number, that means it has 11 electrons rotating in its orbitals around its nucleus. That is sodium. And we have chlorine apart, and its atomic number is 17. And there are 17 electrons rotating towards the nucleus in chlorine. Okay, so this has 11 electrons. That means, look, there is neon configuration over here where neon needs 10 electrons. That means this is stable. Neon is stable, and neon have 10 electrons. That means 10 electrons will be stable. How is that possible? Like 1 is 2, 2 is 2, and 2p6. Understand? This is the electronic configuration of neon, but we have one more electron. That's if we add one more electron to this neon will become sodium. Sodium. So if sodium here has to lose one electron, it has to lose one electron. So this have to be lost from, it has to remove this one electron so that it gets the configuration of neon, so that this atom gets stable. Now where this electron goes, this one electron, it can't leave it away, right? It has to share with another molecule or another atom. So then comes our chlorine. Why chlorine? Why only chlorine? Because there is 17 over here. 17, and for 18 we get the argon configuration. We get argon configuration for 18 electrons. Now there are 17. We need just one more electron for getting stability for chlorine. Now it needs one electron, so we need one more electron over here. We need an electron, and this electron we can add it to chlorine. That means it gained one electron. Right now, this is also stable, this is also stable. That is nothing but ionic bond. You might get a difference, like that is chemical bonding, that is chemical bonding. But remember guys, I told you it's the interlink or the attractive forces between two atoms. Here it's also the attractive forces, but only sodium is just giving one electron to chlorine here. Now chlorine is not giving any electrons to this one, so there is no mutual. Right, so this chlorine molecule gained one electron, but it is not giving any electron to sodium. Chlorine is not giving anything. Now, only sodium is giving one electron to chlorine. Now these both are not mutually sharing. 1, 1. That would make a sense. But this only sodium is just losing one electron and giving to this, and this is not giving anything. That is called ionic bond. Understood what is ionic bond? So ionic bond will only form for highly reactive metals to highly reactive nonmetals. That means that if there is a highly reactive metal, this will give an electron to a highly reactive nonmetal. You have to keep that in mind. So that is what ionic bond is called. Now covalent bond and polar covalent bond are interlinked. So first I'll discuss what is covalent bond, and then you'll get an idea about polar covalent bond. Before that I have to rub this, so just a minute. Now let's go to covalent bond. For this, again, I'll take an example. Just look it carefully. It's super simple, very easy to remember and understand. Now let's take a hydrogen atom over here, another hydrogen atom. Everyone knows this, that hydrogen have only one electron. This hydrogen also has one electron. Now, hydrogen to get stable, what does it need? For helium configuration, that 2 electrons. That means this hydrogen need one more electron to get stability, and this hydrogen also needs one more electron to get stability. Now, what if there is a bond formed between, okay, these are the electrons, assume it. That's where Levy's dot theory comes, but I'll get to that later. Now, hydrogen and hydrogen, one electron in the valency, and this needs one more electron to get complete stability. Now, here comes the covalent bond. The bond is formed between these electrons, and that becomes H2. How? Now, if this one is there, if these both are combined like this electron belongs to this hydrogen, this electron belongs to this hydrogen, okay? The down one to this one, and this one to this one. Now both interlink and forms a bond, that is covalent bond, and one electron, and this hydrogen has 2 electrons now, as it's performed a chemical bond, and this hydrogen even has two electrons. So both are got stable configuration and both are happy. So that is what covalent bond deals with. And coming to the definition, it's the same as the chemical bonding, but mutual sharing. Here, ionic bond, there is no mutual sharing, okay? Here, there is mutual sharing. That one electron, it have to gain one electron. This also have to gain one electron, and both participate, mutually shared. This will give one electron, this will give one electron, both interlink and form H2. That is what is called, okay, covalent bond. And what is polar covalent bond? Here it comes. Let's go to H2O molecule. This is known by everyone. This is water molecule, so it's a very easy example. Now here, oxygen needs 2 more electrons to get stability. I'll show you. Oxygen has, wait a second. So here comes the H2O molecule, and oxygen needs 2 more electrons. How? Like oxygen's configuration depends that it have 8 electrons in total, and it needs 2 more electrons for getting neon configuration. And hydrogen, that has 1, and it needs 1 more electron to get helium configuration. Now for this one, if you donate this hydrogen, if hydrogen is bonded with oxygen, then here you'll get 9 electrons, right? And if you get another hydrogen, again a hydrogen, and bonded over here, there are 2 H's here. These are called hydrogen. So 2 hydrogen forms here, and this will raise to 10 electrons, and done. Oxygen got neon configuration. And what about hydrogen? I'll show you in the Levy's dot theory now. Look, How many electrons? These are the valence electrons for these dots represent the valence electron for the oxygen. That is what called Lewis dot theory. It was proposed by G. N. Lewis, and you have to remember this. It is really important. So the dots represent the valence electrons of that element, particular element. That is what Lewis dot theory. Okay, this is done now. Now there are six. Okay. Now this need 2 more electrons to get stability. Now here 2 more electrons. We need these 2 electrons, one from here and one from here. Now the bond happens that this one electron belongs to hydrogen and this electron belongs to this hydrogen, the bottom hydrogen. Now these all electrons are belonging to oxygen. Now if you donate, if these 2 hydrogens come donate to 1 electron to these, okay, and even this hydrogen will participate in the bonding and it will get helium configuration. How? Because like this, it's got bond, and this is also got bond, and totally this is all bonded. So that is how H2O will form, and that is polar covalent bond. Why it is polar covalent bond? Here oxygen is just taking 2 electrons, and instead hydrogen is just getting 1 electron. Look, hydrogen is getting 2 electrons in benefit, but this one hydrogen of here, this H2, one hydrogen is just getting one hydrogen over here, one more electron. Now this is plus 2, this is plus 1. It is mutual sharing. It's mutual sharing, but it is not correct. Like this is having more electrons, it's gaining more electrons, this is gaining just 1 electron. That is when polar covalent bond are raised to. So this is what polar covalent bond is. So this is polar covalent bond, this one is done, covalent bond is done, ionic bond is done. And coming to the bond length and bond angle, let me erase this. Okay, so let's discuss bond length. Bond length and bond angle are super easy. Just focus, okay? Don't go anywhere. This is one nucleus, 1 electron present over here. And this is, an atom. This is also an atom, 1 electron present in here. Now, what is this atom? It's hydrogen, obviously, because it has 1 electron. This is also hydrogen because 1 electron over there. Now, bond length is the distance between the equilibrium distance between 2 nucleus in a bond. Now, this is known as bond length. The distance from this nucleus to this nucleus is known as bond length. Now, bond length is expressed in angstrom units, and that is equal to 10 power minus 10 meters. Okay? Yeah, in meters that's called 1 angstrom unit is equal to 10 power minus 10 meter, and you represent that in this way. And actually I think I missed one thing. Bond energy. The bond energy, I write it here. Okay, bond energy, to break this bond, boom, you have to break this bond, you need some energy, obviously. That energy is known as bond energy. So simple. So to break this bond between any 2 atoms or more than 2 atoms in a molecule, the energy required to break it, it's known as the bond energy. So simple. And coming to the bond angle. Now, for example, you take molecule H2O. Okay. So what is this thing over here? This structure over here is this one, right? Okay, the angle present here, over here, right? You can see an angle there, right? That angle is now the bond angle. Now, generally for this atom, it is 104 degrees 31 minutes. Or that's almost approximately 105 degrees. Or don't remember this is wrong, this is wrong. You have to remember this one. That's 104 degree 31 minutes, okay? Remember this as the bond length of H2O molecule. You don't need to by heart all the bond lengths because, bond angles, because it's really complex, so don't do that. Okay, that was the whole video. I hope you enjoyed and learned at least something new from this video, and maybe I almost cleared all your basic doubts in chemical bonding. And my sister is also going to upload a video about all the basics like metals, non-metal, valency, etc. So basic stuff. You can also watch that. It may release or it may go on YouTube like after 1 day after this video gets uploaded. I don't know when I'm uploading this. Okay, so thanks for watching, guys. I'll see you in the next one. Until then, bye bye. Oh, wait. Before leaving, subscribe, like, and hit the bell icon to get instant notification whenever I post a new video. And I plead apologies if I have said anything mistaken here. So don't mind. If you know it, just please write it down in the comment section. And if you like it, give me the feedback in the comment section. Until then, goodbye. I'll catch you in the next